Hi dear, today we'll see the rules to make ray diagram for convex mirror. Okay, how the convex in the convex mirror the images will be formed, and we are going to represent that by the ray diagram. Okay, so what is the first rule? Concave mirror, we are having the four rules. Same rules. When it is parallel to the principal axis, means it will be the reflected ray will be passed through the focus. Likewise, when it is the instant ray is passed through the focus, then reflected ray will be parallel to the principal axis. When it is passed through the center of curvature, it is reflected back in the same center of curvature. When it strikes the pole at some angle, it reflected back at the same angle. Likewise, same thing, same rules are there. Slight difference where the image will be formed. Okay, right? First rule, a ray of light parallel to the principal axis of a convex mirror appear to diverge from the focus point. So in the convex mirror, it appeared to diverge. Okay, appear to diverge from the focus point. See how this is your pole, this is your center of curvature, right? This is a convex mirror since it is curved outwards. Okay, so this is your non-reflecting part, right? Okay, so this is your principal axis. When the light strikes parallel, the ray of light is parallel to the principal axis of a convex mirror, it appears to diverge from the focus point. So this is your striking point. This is the focus point will be here. See, first we will draw correctly the reflected ray. Okay, so this is the incident ray. Which one is normal means this is your normal, right? This is your normal. If I extend this is your incident angle, means same angle almost. So this is your reflected ray. So it is reflected ray. It is appeared to diverge from the focus. So if you extend this line, if you extend this reflecting line, this is your focus point. Okay, clear? So it appears to diverge from the focus point. Okay, example. So this is your line which is parallel to the principal axis. So it will diverge. From where it will diverge? It diverge from the focus point. See, this is your incident ray, this is your reflected ray. It appears to diverge like this. Okay, so this is your first rule. When the ray of light is parallel to the principal axis, then it appears to diverge from the focal point. Okay, clear on this? Okay, fine. Next, so, converse of the first rule. The ray is directed towards the focus of the convex mirror will be parallel to the principal axis. For example, this is focal pole, this is center of curvature. For example, this is your focal point. When a ray is focused through this, okay, so when the ray is instant like this, right, that is, it's directed towards the focal point. See, this is directed towards the focal point, then it is reflected back, which is parallel to the principal axis. So it strikes the mirror at this direction, which is towards the focus point, reflected back, which is parallel to the principal axis. Clear? So I'll show how to show this. This is your normal, right? This is your normal. If you extend this normal, this is your incident angle, this is your reflected angle. Clear on this? Clear? So when a ray is directed towards the focus point, then it is reflected back just parallel to the principal axis. Okay, clear? Next, third rule. A ray is directed towards the center of the curvature, reflected back on the same path. Know that. So this is your pole, this is your curvature. So ray is directed towards, example. So when a ray is directed towards the center of curvature, it will strike the mirror and it will be reflected back, right? Reflected back. So this is your incident ray. So what is the incident angle? This is your incident angle is I equals to 0. So R will also be equals to 0. So it will reflect back in the same path. Right? It is directed towards the center. It will not pass through this, but it is directed towards the center of curvature. So it will reflect it back in the same path because I equals to 0. So therefore R is equals to 0. Clear on this? Even when it is directed towards like this. See? So this is your incident ray. When it is directed towards the center, it will be reflected back in the same path. Okay, directed towards this, it will not enter here itself it will strike and reflect it back. Okay, next, and the fourth one is a ray incident to the pole reflect with the same angle. You know that this is your pole. When a ray incident on this pole, for example, it makes 30 degree with the normal, then it makes a reflected angle also 30 degree. Simple. Okay, ray incident to the pole reflect with the same angle. This is the center of curvature, this may be your focal length. Okay, next. So how the images will be formed in the convex mirror, we'll move to the next part, right? Okay, so only two where the objects can be placed, only two possibilities are there. Either the object may be placed at the infinity or to the finite distance from the mirror. Okay, that means between the pole and the infinity, right? First we'll take the at infinity. When the object is at infinity, then definitely we'll take the rays are parallel to the principal axis. So what is the first rule? Says that when the rays are parallel to the principal axis, when the rays are parallel to the principal axis, it appears to diverge from the focus point, right? It appears to diverge from the focus point. Example, this is your normal, then it will be like that. This is your incident angle, means your reflected angle will be like this, right? So it will diverge like this. Approximately I will drawing, it will diverge like this. Okay, so your focus point will be here. It appears to diverge from the focal point like this. This is your focus point, this is your pole, this is your center of curvature. So it will be diverged like this. Okay, clear on this? Okay, so when the object is at infinity, so the light rays will pass through the parallel to the principal axis. So what is the rule? If it is the incident light is parallel to the principal axis, then it appears to diverge from the focal point. So it appears to diverge from the focal point. So everything is diverging, it will never meet. I told you earlier itself, you need at least two rays to get an image. Okay, so it is diverging, it will never meet. So it appears to converge here, right? It appears to converge here. Your image will be formed here at the focal point. Okay, so this is your image. So what is the position of the image now? The position of the image is at focus point. At the focus point. What is the nature of the image? What is the nature of the? It is real. Virtual. It is formed behind the mirror. It is virtual, it is not real. Virtual and erect. Virtual and erect. It is point sized, since it is from point sized. Okay, so it is a virtual and erect image. It is point sized and its position is at focus point. Okay, and the object is at infinity. Okay, clear? Next one is the object between pole and the infinity, that is the object is at a finite distance from the pole. Okay, we'll take some here. The object is here. So we'll take one ray, this parallel to the principal axis. Then it parallel to the principal axis means first we'll draw the normal. Extend this. This is your I. So this will be your same angle R. So this will be divert. It will reflect at this. Okay. Okay. From where it will be diverging? It will be diverging from the point of focus. This is your focal point. Okay. Rays will be diverged from the focal point. Okay. Next, one more ray will take. Then only we'll get where the image will be formed. One more ray is when the ray pass through the directed towards the center of curvature. We'll draw directed towards the center of curvature. Okay, directed towards the center of the curvature. When the rays pass through the center of curvature, it will reflect it back in the same path, right? So the meeting point of these two rays, this is your reflected ray, this is your reflected ray. The meeting point of this is here. Okay, okay. This is your focus point and this is your image. Your image will be formed here. This is a pole. So your image will be formed between pole and the focus point, and the image is virtual because it is behind the mirror, virtual and erect. Its position is between the focus point and the pole, and size is very small when compared to the object. Okay, clear? So what is the position between P and F, that is pole and the focus point. And what is the nature of the image? It is virtual and erect. What is the size? Small size. Small size image. Clear on this? Okay. So only two images can be formed. The position of the image will be at only two places, at the infinity and between the pole and the infinity, that is a finite distance from the pole. When it is infinity, the object, the position of the object is at focus point. When it is at a finite distance, the position of the object is between the pole and the focus point. Clear on this? Okay. Then we'll move on to the sign conversions for spherical mirror. Okay. Because we are having, see, if you are looking at this images, object is somewhere, your object it is above the principal axis, and you are getting the image at the below the principal axis. Either it may be in the left side of this mirror or right side of the mirror. So you need to apply the signs also. Okay, sign conversion is very important in the spherical mirrors. Okay. So before that we'll learn this terms. What is symbols? Okay, U is the object distance from the pole. We are going to take this as a image distance from the pole. F is your focal length. That is, what is the focal length? The distance between the focus point and the focal. Height, H is the height of the object, and H dash is the height of the image. Okay. So we are going to apply the sign conversion based on the Cartesian plane. Know that Cartesian plane. What is the Cartesian plane? That is your xy plane, right? So your xy plane. This is your x-axis, this is x dash, this is y dash, right? This is your Cartesian plane. We are going to fix the mirror. This is your origin, right? O. We are going to fix the mirror. First take the concave mirror. Your concave mirror will be like this, right? Like this, right? We are going to fix the pole of the mirror with the origin. Okay. What are the sign conventions? Here the x-axis is positive, here this side negative, this y-axis is positive, here this is negative. Same thing we are going to apply here. Okay. When the for example, take the concave mirror. Here in the concave mirror, the object is always present in the side, right? Either at the infinity or at the center of curvature, or between the center of curvature and focus, or between the focus and everything it is in the left hand side of this, right? That is in the x dash. Okay, then always this u value. U means what? Object distance from the pole. This is your pole. The object distance from the pole is always negative. Clear on this? Okay, clear on this? Okay, next. What about this image? Image, if you are getting the real image, means it will be in front of the mirror. So this is your back side. In front of the mirror, you will get the real image. Okay, real image means again what? The object, it lies in the left side of this, left side of this, right? So V will also be negative when the image is real. Distance of the image is negative when the image is real. Okay. When the image is virtual, think about that. Virtual means you will be getting the image behind the mirror. So it will lie in this quadrant, right? In the first quadrant. Then you will get the image of the object from the pole is positive. When the image is virtual. Clear? Next, what will be the focus? Always your focus point. This is the center of the curvature. This will be your focal point. It always lies here. Okay. Then focal length will be what? Focal length f equals to always the distance between the pole and the focus point. So it is always negative. This is always negative. It's not going to change, right? Then what about the height of the object? So always we'll place the object above this principal axis. We'll always place this, right? So above this, what is this is your y-axis. For example, this height you are going to measure with the y-axis, right? Y-axis here always it is positive. But in case of the image form, it is real and inverted. It will be measured in this y dash axis. So you will get minus value, negative value. Okay, you may get virtual and erect image also. In that case you will get positive, right? So h dash may be negative when it is inverted image. Inverted image you will get real and inverted in this direction, downward direction, inverted. When h dash equals to positive when it is virtual image. This is your virtual image, right? This is your real image, real and inverted. Clear on this? Okay, this is your sign conversion in case of concave mirror. In case of convex mirror, same thing. Draw the Cartesian plane. This is x dash, y dash. So your mirror will be like this, curved outwards. This is a non-reflecting part, right? Same thing. What is u? U is always placed at infinity or between the pole and the pole and the infinite distance or at the finite distance. So always your u will be, this is to the left side, right? Here the x value is negative, right? So u equals to negative. Okay, what about v? Image is always formed at the either at the focus point or between the your this is your focus point. Image is formed when the lines are parallel, the image will be formed at the focus point. uh, when the image sorry when the object is at infinite distance, you will get the image at the focus point. When the object is between pole and some distance here, you will get the image between focus and this pole. Okay, so you will get the image either at here or here, small size image, right? So the distance is always, here it is placed in the x axis, here it is positive. So always v is positive, always, because we are not going to get the image here. Okay, right? Next, what about the focal length? Focal length is here in this direction. This is your focal length, right? Focal length is your always positive, because in this it is lies in the first quadrant. Okay, right? Positive. Next, what about the height of the object? H equals to, it will always lie above this principal axis. Height always measured with the y axis. So it is y direction. In the y axis it is positive always. Next, what about the h dash? Image is always present in this. You will get a erect image, so it will be on the principal axis. So we will measure with this y axis only. So it is again positive always. Okay, whenever the image is inverted and real, you will get the negative image. In the case of convex mirror, you will get only the virtual and erect image. So your image height will always be measured in the positive always. Okay, clear on the sign conversion? So it is very important while doing the numericals. Okay, thank you.